Raluca, just say Gina. It's fine. Because if you're not good or well aware of غ, it's غنى. It's either غنى or Gina. I don't mind if you say any. I swear. مش رح نسمي التالي أول واحدة العقدة من الثانية كان
Hello, everyone. How is the sound now?
I can hear you well, Raluca.
I assume everyone. Okay. Wait. Okay, sorry for that. Okay. Restore thanks. Okay, so we're good to go.
Hello.
Hi, beautiful.
Hello, dear. Hi.
So we have a lot of people that should be joining us during the webinar. They're a bit late, maybe they're Lebanese. But we should start and they can watch the recording. Sure. So I'm so very pleased that today I have this special woman as our guest as part of 2022 Energy Efficiency Marathon. I have been practicing all day the way I should be pronouncing her name, and hopefully I will get it right. Okay, G? No hard feelings. So today with us, we have Erna Anand.
All is good.
Great.
You did well.
She's one of the women in Lebanon that I personally admire a lot because of her involvement in all kinds of activities promoting sustainability and energy efficiency. And let's hope she will be more involved from now on and have other women supporting her. So she plays an influential role in the development of high performance design. She combines sustainability vision and practical experience to deliver a solution-based approach for buildings, master plans, and cities. She has an experience of over 10 years in sustainability field, and I'm sure she will have way more. But I think if we add all the activities that you have in a year, we can say you have more than 10.
Thank you.
She led and coordinated manifold iconic projects to achieve effective sustainability outcomes while identifying and implementing adequate strategies to achieve net zero energy, water, waste, and carbon while following regulations, codes, and standards. Now, here comes the interesting part, because I am not sure how she can do this. She's an En-ROADS climate ambassador, climate leader, true advisor, envision sustainability professional, excellence in design for greater efficiencies expert, Eco District accredited professional, well-accredited professional, lead accredited professional. When do you sleep? Certified lead professional.
You can skip,
she's a member.
Fine.
It's so many things here. She's a member of ASHRAE's task force for building decarbonization, a member of Association of Energy Engineers Lebanon chapter, and in the Council of Women in Energy and Environment Leadership, and a mother.
Right.
So with us today, this wonderful woman that I'm pretty sure she has 50 hours per day to do all this.
Thank you so much for the introduction. Thank you, Raluca. You're pretty yourself, and you're doing hard work since the beginning of the year. So thank you. I'll be sharing my screen, and please do let me know if you can see it.
I can see it.
Perfect. Okay. Perfect. So As we all know, climate change is widespread, it's rapid, and it's intensifying. And some trends are now irreversible, at least during the present time frame, according to the latest IPCC report. So what is really alarming is that climate change in the 21st century is projected to have severe detrimental consequences for both the environment and the societies worldwide. It is caused by man-made greenhouse gas emissions. Now, why are we here today? Because we must work together to significantly and rapidly address the greenhouse gas emissions associated with the building industry. The UN climate change report, Code Red for Humanity, as you can see here, highlights on the fact that the global warming of 2 degrees Celsius will be exceeded during the 21st century, unless rapid and deep reductions in the CO2 and other greenhouse gas emissions occur in the coming decades. So the only way to prevent exceeding this threshold is by urgently stepping up our efforts and pursuing the most ambitious path. So what is really the challenge? The challenge is to focus on decarbonizing our built environment through carbon negative construction and transforming our current buildings to more energy efficient, as this can reduce emissions and support more equitable communities. Now, this is really an alarming number. Population growth is anticipated to reach to 2.4 billion, which is equivalent to 32% increase in the next 30 years. What we need to ensure is that those extra people on this planet Earth end up in buildings that are really with net zero targets. So we need to build in line with those targets. So this slide shows some important statistics illustrating the annual production-based emissions of the CO2 measured in tons, noting that approximately 38% of the energy related to greenhouse gas emissions are attributed to the building industry. I'll give you some numbers to relate. It is estimated that approximately 255 billion square meters of buildings currently exist in the world, with the addition of roughly 5.5 billion square meters every year. This really means that a city the size of Paris is constructed every single week. Thus, understanding the whole life carbon emission is important in creating reductions and credible pathways towards net zero. So before I start with the way forward in this presentation, I'd like to highlight on certain definitions that are really important to relate to. So the carbon dioxide equivalent emission is really a parameter which approximates the time integrated warming effect of a unit mass of a given greenhouse gas relative to the CO2. And the CO2 that comes from operational carbon and embodied carbon is the same carbon, and we have to treat both, whether embodied or operational. What is embodied carbon? Embodied carbon is the emissions of an asset is really representative of the total greenhouse gas emissions and removals associated with both materials and construction processes throughout the whole life cycle of an asset. Now, the operational carbon, which we are familiar with, especially the engineers that are currently working in sustainability, it refers to the greenhouse gas emissions associated with the energy consumed and water supply and wastewater treatment of an asset over its life cycle. Now, the word that we want to highlight on in this presentation is the whole life cycle assessment, which is really the method to quantify both, whether embodied or operational emissions of an asset during the life cycle. Now, why am I highlighting on this word? Because really, if we cannot use the whole life cycle assessment, we cannot achieve a zero building. Working within a whole life cycle framework allows us to have accurate judgments, to balance the savings of both operational and embodied. So what are the benchmarks? What are the codes and standards that we relate to? Now, what we are using is EN 15978 standard, which provides the calculation rules for the assessment of environmental performance of new and existing building. 2011, by the way. So let us see how does the whole life cycle assessment look like. So you can see here that we have stages from A to D, and these stages are divided into modules. And this is basically the whole life cycle of the building. Now, stage A represents the product and the construction, and it has modules from A1 to A3 and modules from A4 to A5. The A1 to A3 represent the product stage and the manufacturer stage, which really accounts for the carbon emissions associated with the cradle to gate processes. The modules A4 to A5, they represent the construction stage processes. So these account for the carbon emissions associated with the transportation of the material to the site of the construction. I'll give you an example like material waste, construction plant, and machineries. Moving to stage B, here in stage B, the building is in function or in use, and it is divided into 5 modules, B1 to B5, and they relate to the embodied carbon. And then we have B6 and B7, and they relate to the operational carbon, which is basically the energy and water. Now, stage C is the end of life, and this stage is associated with the demolition and the waste processing. And here, the end of life varies among certain certifications. So some consider the life of a building 50, some 60, especially in LEED, they consider it 60, so it varies. So stage D is beyond life benefit, and this module accounts for the benefits or burdens associated with the repurposing of the building elements, like the material that are discarded at the end. Now, this module in specific, module D, is not included in the whole life carbon emissions as it is outside the building system. However, the value of it is important in the context of circular economy, especially within the reuse of the material. So can we reduce operational embodied carbon? Definitely we can. So if we start early in the design, as you can see here, I'm portraying on the x-axis all the project design stages from the pre-concept stage up until the operation stage. And we definitely do have the ability to reduce the operational carbon and the embodied carbon from a conventional or business as usual case to a more advanced, sustainable way of thinking. Okay, so here we show the operational carbon and the embodied carbon. A design approach for reducing operational carbon typically includes a lean design. And in a lean design, we care to reduce energy consumption. And this is essential to reduce the carbon emissions. Then we look to a clean design. A clean design is once the building form and orientation and facade is optimized through energy modeling, we have to develop a strategy to be able to reduce the remaining energy and focus on minimizing energy and optimizing all the system within it. Then we move to the green design, which is the use of renewable resources, and any type of renewable resources is considered a green design. Now, if this renewable resource, on-site or off-site, is not enough, then we go to the offsetting and offsetting the remaining carbon through the recognized offsetting framework. Now, what about the embodied carbon? The embodied carbon thinking considers building nothing, which really optimizes opportunities to repurposing and reusing. Building less, meaning that if I can look more into the space utilization, that would really serve my embodied carbon decrease well. Building clever, and this is through the use of smart materials to reduce embodied carbon, and then minimizing waste through the use of prefabrication to minimize the waste on the site as well. So the presentation from here on will be divided between operational carbon and embodied carbon, starting with the operational carbon. In the operational carbon, we will be addressing operational carbon emissions, and it is very essential to begin with strong passive design and to minimize the need for active systems. So first, what do is we look at how we can really maximize energy efficiency. We need to start with reducing energy demand, which will limit eventually the quantity of on-site and off-site renewables needed to offset this energy consumption. So what are typical energy efficient strategies we look at? We look at the high performance building envelope, we look at energy efficiency of the equipment and appliances, smart building controls, energy efficient lighting, and so on. And how do we do it? It is really about balancing all design considerations to identify the most sustainable. Modeling assists in visualizing the results. So for instance, here you can see that the window size has implications on both the daylight, the heating, and the cooling requirement, which in turn have a knock-on impact on the natural ventilation strategy. Moreover, the window area has consequences on the daylight, acoustics, and air quality. So what we need to do is we need to identify the optimal combination of inputs and achieve the required design outputs. And after that, we have to look into renewables. Here we are considering the on-site renewables. And really, it's now common to incorporate on-site renewables to produce emission-free energy, which offsets operational emissions. So for example, solar photovoltaics is typical option for creating energy on site. We see the ones that are roof integrated, we see the ones that are ground mounted arrays on parking structures, we see ones now on building facades, we see we consider the ones that are off-site, which we will look into in the next slide. But then once we want to look at the PVs, we can look at various other parameters, which is simple, which is more cost effective. We can look at less structural needs. So the roof integrated it may cost less because I don't need structure for it to be built, like the ground mounted arrays and the parking structure and so on. At the end of the day, we care about having renewables to cater for all the energy demand that I'm needing in my buildings. So what about the off-site renewables? Meeting the energy needs of a project may not be possible, as we said, from the on-site renewables. So we might need off-site renewables necessarily to achieve the carbon neutral building operation status. And the off-site renewables may vary in contractual agreements, including direct ownership and the power purchase agreements that are common and available. Next, we might want to consider also managing our net zero operations, and that would be by ongoing monitoring and tracking of energy consumption and renewable production that is necessary to understand the building carbon emission, and that is a really important step. We need to understand how much our emissions to be able to cater for them. So the utility bills, for example, or the building energy management system can support the review of building system emissions. The new construction projects can use predicted energy and carbon performance to compare against actual energy consumption and emissions. And that it is known of the EUR, or the energy use intensity. So we use it to cater for it. So we use it to model, to change, to optimize. So for example, we can study if the refrigerants from the heat pumps and other refrigerants and fire suppression system have leaked or evaporated. So what do? We maintain the energy efficiency, we minimize the peak energy events, we manage our energy consumption and production, we adjust system control for efficient operations, we purchase additional renewables, and we track the embodied carbon related to the product replacement. Now, a word that we have been lately hearing of a lot, which is the electrification and the minimization of the on-site fossil fuel consumption. Our enemy are fossil fuels. Fossil fuels are the source of the carbon. And the carbon neutral buildings minimize or eliminate on-site natural gas or other fossil fuels. So we need to get rid of all the fossil fuels that we are using. Building electrification combined with energy efficiency can reduce the air pollution and assist with better grid management. Now, as you can see here, the critical consideration I have displayed is the energy efficiency equipment, the high capacity electrical panels, electric chases and conduit runs, and electrical outlets near gas equipment. Moving to the building grid integration. So the building grid integration allows buildings and the electrical grid to coordinate energy supply and demand in an attempt to really optimize the energy consumption, to reduce the demand, and offer more clean energy and provide, the most important thing is to provide a reliable electricity supply. So we have been hearing a lot about the distributed energy resources, or the DERs. And what are they? They're like solar photovoltaics, wind turbines, energy storage, electric vehicle and combined heat, and power plants. We've also heard about the demand response that allows grid operator to adjust the building heat, cooling, and lighting, and etc. So this is needed to reduce the power consumption and minimize the community-wide service impacts. So what should building operators do? They can simply adjust when grid energy is consumed and avoid any peak energy rates. And this is common in Lebanon. So the balance of energy resources will improve how we use the energy and support a modern grid that is capable of supplying more renewable energy. Moreover, we've also heard about the grid-friendly building strategies that include efficient system peak shifting and flexible loads, smart controls, the thermal mass storage, intelligent grid integrated communication, smart system, and so on. Moving to the low global warming potential refrigerants. So most refrigerants are high global warming potential. We've heard of refrigerants that have no CFC content, but what about global warming potential? We're interested in this parameter because that can make up, the effect of it has 1,000 times more polluting effect than the carbon dioxide alone. The fire suppression system and heat pumps are common sources of refrigerant. They may also be sources of emissions from leakage or evaporation. So what do we need to consider? We need to compare the equipment efficiencies. We need to look at various refrigerants. We need to minimize requiring refrigerants and considering equipment with medium or low temperature refrigerants. So how do we calculate the carbon neutral operations? We really need to look at 4 steps. We need to determine the annual energy consumption and greenhouse gas emissions. Then we need to deduct the energy production emissions avoided through the efficient design. And then we can calculate the annual greenhouse gas emissions per location. And finally, secure offsite renewables to cover the remaining emissions. Now we're done with the operational carbon. We'll move to the embodied carbon. Now, the embodied carbon can be minimized by thinking carefully about the spaces that will be needed, and we should prioritize the reuse of existing structure. So reuse is the key word under the embodied carbon big title. So within the engineering design, we typically propose a framework. When it comes to embodied carbon, we look at building nothing. I've mentioned it earlier in this presentation. Building nothing, which is be able to invest in opportunities for repurposing, building less or maximizing the spatial utilization, building in clever using smart material. If it's not possible to refurbish an existing building entirely, the reuse of material during the construction to build a new development should be also explored. And then finally, minimizing waste. And that could be done through various methods, but a most common one lately is the use of prefabrication and even prefabrication on site so that the transportation emissions can be deducted. So low embodied carbon material, construction materials alone are responsible for about 11% of all global carbon emissions. The embodied carbon refers to the total impact of human-induced greenhouse gases emitted from the material extraction. We're continuously extracting material, manufacturing it, and transporting it. And that is really not useful in the life of the building. So total material selection, again, should be used and to reduce the global climate emissions, definitely. And the critical considerations that I've mentioned here in this slide are reducing the number of materials, reusing, again, prioritizing durable materials, looking at EPDs, designing for deconstruction. Also, typical carbon materials that we see now lately with the market maturity, we see material that are really eco-friendly, like low Portland cement concrete. We see wood, we see reused and reclaimed concrete, high recycled content, concrete from fly ash, and so on. So this is also important to highlight on. So we've been addressing climate change traditionally, and we have been working around the word sustainability for so many years now, and we've seen that we were able to target the operational carbon by looking at all design strategies, and you can see here at the currently achievable. So the yellow represents the operational carbon scenario, and the embodied carbon represents the pink. And you see that before the operational carbon, we had much focus on it. But now with all the strategies that are being implemented at the level of the passive design, at the level of efficient equipment and appliances, implementing, let's say, natural ventilation, looking at high COPs for HVAC systems, and so many other things, it helped us to decrease the operational carbon in so many various ways. And we do have common strategies that are being implemented. But now the focus and the main target and the significant comes to the embodied carbon. So it has a significant today at this stage that can represent 40 to 70% of the whole life carbon in a new building. This is the information source is by Leti, embodied carbon primer. So addressing climate change has traditionally focused on reducing carbon emissions from operational energy consumption. However, as buildings become more efficient, operational carbon is reduced. And this means that the embodied carbon represents the higher portion, and we need to address it. Now, thanks to Leti, this is also one of the, let's say, prettiest targets and reductions that has been developed by Leti and have in the series that had been set out. And this includes targets for reuse material. So let us together look at the targets that have been put, noting that the dark pink color represents the embodied carbon target. The yellow is the operational energy that follows the building regulations and the operational energy balance, which we are able to cater for and achieve. So once you look at the business as usual, you would notice that we are starting in residential and commercial and school. We're starting with high content, around 800 kilogram CO2 emissions per square meter and 1,000 and 1,000. Now, once we look at the 2020 target, we see that there is reuse of material, 30% of reuse material, and lots of percentages of good material, reuse material has been invested in. Now, this target is also decreased from 500 to 300 and 350 in residential and commercial offices and schools. And eventually, once we really want to reach the whole life net zero target, we are decreasing this target to zero by reusing 100% of the material on site. So it's all about reuse. Now, as a conclusion, what we really need to do is really involve all disciplines in the project at a very early stage. We need to define the strategies, measure current emissions footprint, identify emission reduction and opportunities, and then look at setting targets and goals, because as you can see here, without setting the targets, without setting the goal, without pledging and committing, it is not possible to reach your aims. And then implement a strategy that is doable, integrated within the project decisions with other disciplines, integrate the emission impact into all decisions and investments, and then track and report your progress, because it's all about the tracking throughout the whole building life. And this is through measuring and monitoring the project, disclosing the results, and adjusting any necessary important values. So this is it for me. I hope you enjoyed the presentation. I can just add a few words if you like me to. So
Yes,
if you have
please.
questions, I can address it. But yeah,
We do have some questions, but please.
Go ahead. So I mean, the most important thing is really to commit to the whole life cycle assessment on all the projects. And lately, ASHE has been doing lots of work, and there are lots of collaborations among other research groups and people of codes and disciplines. So we will be seeing lots of guidelines, and ASHE will be providing a very efficient guideline as well. We need to take it in and implement it to all our projects at the very early in the design. Most of the clients are now really aware of the targets. Their mission is really to address climate change as well in their projects. So by working together with the stakeholders, with all the disciplines, with the client, and the contractor definitely, and the manufacturer, we can really reach all the goals that I have mentioned throughout the presentation. And really, the ability to be able to define the net zero is not as hard as it seems. So there are typical green building certifications, such as LEED, such as we all know LEED, and there are other green building certifications and guidelines and codes. So it's good to commit to them for a nice framework. but there are now also other certifications like LEED Zero for operating with zero emissions and so on. So we also need to look at certifications that consider the zero emissions of the project. And definitely the commitment is really important, because without the commitment we cannot be able to monitor on the long run. So develop a constant and transparent carbon intensity and benchmark data and take it from there, and definitely establish wider collaboration and let everybody, existing and new constructed building, adopt this way of thinking, so that we can really relate and on the long run with those ambition requirements that Letty is portraying, and Tipsy and Ashe and everybody. So yeah, this is it from my time.
Thank you. We have a question from Mr. Sharbel, or he is asking you if you can introduce the calculation process of the embodied carbon and the codes and standards for this calculation.
Definitely. So I don't have it on the slide now, but if you like to email me on my email, I'll provide my email on the chat now. I can definitely share one with you. So so the whole life carbon, I mentioned the code. I'm just writing my email. It's my full name at gmail.com, or you can use also my other email, rena.tannan@dar.com. So that's my email. You can email me for any question or samples as well. I didn't go, maybe the next webinar would be adopting certain case studies. So the standard that we are looking into is the EN 15978, and it takes into consideration all those life stages, as I mentioned, along with the modules, and they all relate from the moment the building is being built, from the materials that are being extracted, manufactured, and transported to the site, then the construction, and then the end of life and demolition of the project, inclusive of the operation. So we look into that, and we look at each and every structure of the building. So I'll just give you an idea. You have a table with all the foundations, with the walls, with the facade, with everything, and the material, and each material's contribution. And then you have this EPDs, where you really get the information about the material and how it's being made. And then you can, from there, optimize and maybe check other types of material that can be available and more sustainable and more better in terms of embodied carbon.
Thank you. Yes, the webinar recording video will be shared with all of you, and with the rest of the registered people that didn't have the time to be here. I have another question for you. What are the challenges and opportunities to decarbonization?
So basically, we were not really seeing much of people that are adopting the whole life carbon assessment, or the whole life cycle assessment. So we need all the projects, all large scale projects, all types of typologies of projects to really commit. We need to incentivize the client and the developer and all the disciplines. There should be awareness about the whole process. There should be awareness about net zero targets, about the decarbonization. There should be definitions for people to know and relate to once we say embodied, once we say operational. And most importantly, there should be an alignment in the international strategies and policies, so that we can commit to and follow and benchmark against. So the commitment to reduce the building carbon operation and embodied should really be clear, so that you can follow the right strategy throughout the whole process, so that once you design the building and then tell the operator and the contractor how to maintain it, how to continue working in a way that we're really keeping up with all the innovation in the industry, with all the right strategies that are applicable to all types of climates, to all types of typologies, to all operation schedules and timing. How I see it that there is the opportunities that I see, in my opinion, is that there is awareness. There is, at least, we started to see collaboration. We started to see partnership. We started to see people that want to know, but are afraid of this a new way of addressing the whole life cycle assessment. So I mean, we need to challenge ourselves. We need to challenge our design criteria at the very early stage in the design, as I mentioned earlier. And the incentives, providing incentives, that would be really good. Everybody's supporting. We're seeing lots of green funds. We're seeing lots of supports from certain governments. We saw in COP26 that so many countries committed to the climate change targets. So I think, in my opinion, that's an opportunity, and we should really invest in it.
So what would you think that the key actions should be today based on everything?
I think the most successful would be, especially in my work, would be adopting explicit targets, developing consistency, transparency in carbon intensity, and benchmark targets. That would be the most important thing for each and every project. We should like exceed our common practice in terms of sustainable design, in terms of energy efficiency, water efficiency, waste management. We should exceed it and look into carbon more, highlight on the carbon emissions, and really be able to have an integrated approach and not just design the project, but coordinate with the contractor and coordinate with the operators, so that when the building is being operated for those 60 years or less or more, we're ensuring that our design is really successful. Those carbon emissions has been reduced and are being reduced continuously, and there is really awareness among the operators of the building of how to really operate their buildings to commit to whatever commitments are applicable to the project.
We have a question from Nancy. Nancy, thank you for your question. How will embodied carbon will help in the long run?
Help in the okay. So at the end of the day, this I said in the beginning that carbon, from operational carbon or embodied, it's the same carbon. We need to treat it, whether it is emitted from the way I'm operating my apartment, I'm operating my office, or from the material. So the embodied is due to the material and the construction practices. So if I am to educate those manufacturers about the good types of material that can be used, the ones that would really not contribute much to the carbon emissions, and have it available. So we need to have projects in regions where there is market maturity, where you can go up and reach out for a manufacturer that can provide you with those eco material, with those reused material, recycled material. If they're not available, then we cannot really address the issue. But there is market maturity. We are seeing lots of market maturity. In UK, there are more than 100 manufacturers that are currently, that do have a database, and they are in line with the embodied carbon commitments. So this is what's really important to address it, to address the fact, to tell the client that it is okay to use concrete from fly ash. It's okay to use reuse materials, to propose it, to propose and say, well, wood is a good material. We need to invest in wood, and we should show a baseline, and then we should show the contribution once we move from a typical conventional material to a new material, how much percentage we're really saving in this process. So once we do that, the client would see that those percentages are achievable by just shifting in the specifications to the contractor to certain type of good material that would contribute to a better cause. So once they see it's doable, then it would be common, and then you would see it among other clients and among other projects, and that's the aim after all.
Thank you. Thank you. I think we all learned something very, very important today. And hopefully the next webinar will be even more important.
Studies. Definitely. Next webinar should be on case studies, and then that would be, I think, in my opinion, that would be really interesting. And I hope we'll have people on board as well.
Yes. Well, look, Nancy is asking, how can she contribute?
So I'm not aware of her background and her type of work, but she can definitely contribute by awareness. So we need more people to know about decarbonization. We need more people to be aware of the regulations. We need people to talk about decarbonization in line of what might happen. So at the beginning, I spoke of the climate change, and I related it to really to the challenges and the solutions and what we have been seeing lately. So COP26, the natural disasters, we're seeing trends that we've never seen before. And in order for us to be able to maintain a life on Earth, we need to go this extra mile, and we need to do it really quickly and in a way that is implementable. So setting targets without being able to achieve them is not the right thing to do. But by spreading awareness, people would want to know more and design in a way that is really in line with those implementable targets. So step by step, we can all reach this ultimate goal. So in my opinion, I think no matter what your background is, I think awareness and spreading the word and telling people that it is not hard to do. It is, you shouldn't be afraid of learning about it or implementing it or really checking what's happening lately. So the whole life carbon assessment, it is doable. We've been doing it. We've been checking all the markets. We've been implementing it in projects. So the fact that it is implementable and someone is telling that it can be implemented should push you to know more and to dig more and to spread the word. And that is how we will be able to not only brief clients, but also designers. We really care about designers implementing, getting rid of the conventional business as usual design and just adopting highly sustainable design practices in energy, in water. We need to decrease our energy demand in the building so that we can cater for it in renewable energy, whether on-site or off-site. So those practices should become as common as possible so that we can really move forward and contribute to the ultimate cause of mitigating climate change and not just simply adapting to it and to all the natural disasters that are happening worldwide.
Thank you. And you have the exclusive supporting you in anything you want to create awareness for. Thank you, everyone. And we will see you next week.
Thank you.
Bye.
Bye.